Alright, so continuing on with solving proportions here, there's some good notes at the top here for setting up a proportion to solve here with similar shapes. Remember, similar shapes, they have, they're the same, they're the same looking shapes and everything, they're just different dimensions, okay? So like when you're talking about triangles, all the angles are the same, and everything, and all the sides are proportional, just they're different sizes, okay? So it's like taking a bigger one, shrinking it down, or if you have a smaller one, expanding it. We talk about scale factors and all that good stuff. All right, so anyway, make sure you look at these similarity statements. So we're trying to figure out x in this drawing. So we can use any other side, but we are going to want to use side EF. So you can start this off any way you want. I don't want to deal with the decimal, so I'm going to say that side DF over EF is going to be equal to, because again they're similar, so the fraction should reduce down to the same thing on both sides. So if I go DF, that means I have to go AC because they're the first and third. And then my denominator was EF, so those were the second two, so that means I got to go BC. Okay, you don't have to do this for all these, but I'm just showing you how I'm getting these. Again, I could have picked anything, but I went with DF. Okay, once I committed to DF, everything else kind of falls in place then. So DF was 13 feet. EF is X, that's what we're trying to figure out. AC is 10, and then BC is 12. So 12 times 13 then should be 156. So we get 156 equals 10x. So that means x is equal to 156 divided by 10, so it's going to be 15.6 feet. All right, so it's really just about getting those similarity statements set up. All right, moving on down then to the second one, we have, 1, 2, 3, 4. We have a quadrilateral down here. Strange looking quadrilateral. We're not really worried about naming this stuff. We just want to set up some proportions here. So first up, we're trying to figure out x. So this is d over here. If you can't see that. So that's dy, so we need dy, and the only other measurement we have is AD. So we're going to go dy over AD, so that means that's going to have to equal, if we went dy, so dy was the second two, it means we're going to need NT over AD, so AD was the middle two, so we have to go EN. Okay, again, I'm just matching up the order of the letters there. So dy was our x, and the denominator was AD, so that's 3.5, is going to equal NT, which was 3.5. Got two 3.5s in here. And then EN, 2. So that means we're going to get 2x equals 3.5 times 3.5 is 12.25. Divide that by 2, and we get 6.125 centimeters. Okay, so again, just setting up the proportion is the hardest part. Once you get to here, just cross multiply and solve. But you got to be very careful in setting up your proportions. Make sure you're using the correct sides. All right, so next up here, it's a little confusing because we have a triangle inside a triangle, but we have triangle ACD is similar to triangle ABE. So ACD is easy because it's this big one, but let's just redraw them. So again, ACD, and then my smaller triangle was ABE. So I'll try and draw that a little bit smaller here. All right, so an ACD, this whole side, AD here, is 8 and 4, so that's 12. We don't know this bottom side, that's X, but in ABE, we know that this side is 8, and the bottom there is 5. So we're trying to figure out X down here. So we can go X over 12, 5 over 8. They already match up. You can see there. I'm not going to write out a congruent statement here. So X over 12 equals 5 over 8. Again, like I had CD down here, CD, and then BE, BE. They all match up in the congruent statement. So that means we're going to get 8X equals 5 times 12 is 60. So that means X is going to equal 60 divided by 8. So 8 goes into 67 whole times and a half, so 7.5 centimeters. Over here then, we have two triangles. I'll write out the congruent statement for this one. So we have 6/10, and we're trying to figure out, we could have 6 over 10 and then 3.6 over x, but I'll set up the congruent statement here. Okay, so this is QV over RV. So if I go QV in this numerator, that means I need to have TS, which is good. And then since I had RV, go RS. All right. So again, QV was 6, RV was 10. So we had 6/10 equals TS, so 3.6 over x. So we're going to get 6x equals 36. 10 times 3.6 is 36. We'll get x equals 6 centimeters. All right, finally here then, we have a couple ones we're going to try and set up our own diagrams. It says, Kishan is 5 feet 6 inches tall, casts a shadow that is 1/4 his height. At the same time, a nearby tree casts a shadow that is twice Kishan's height. Write and solve a proportion to find the height of the tree. All right, so he's 5.5. He's 5.5 feet tall. The shadow is 1/4 his height. All right, and the shadow is 1/4 his height. So if you think about that, 1/4 of that you just divide it by 4. So 5.5 divided by 4 is 1.375 feet would be the height, be the length of his shadow. At the same time, a nearby tree casts a shadow that is twice Kishan's height.